Hi friends, are you ready to master the topic of polynomials? Then this video is for you. Because in this video, we are going to be looking at the key concepts of polynomials. And we'll be solving some important questions on this topic. I'm going to show you the tips and tricks on how to solve the sums. And if you find this video useful, do hit the like button and share it out with your friends. And do check out my website, manochaacademy.com, for more questions for you to practice. And friends, as you know, practice makes you perfect. So I want you to pause the video right here and go and get a pen and paper so that we can solve the polynomials topic together. So let's dive right into it. Let's start with the first important concept, which is if px is a polynomial, zeros of the polynomial are those values of x, okay, which make the polynomial 0. For example, let's take this polynomial px equal to x square minus 5x plus 6. Now to find the zeros of this polynomial, we need to set this polynomial as 0. So this will be our equation, x square minus 5x plus 6 equal to 0. Now to solve this equation, we can factorize the left hand side. So let's do middle term breaking. So this is going to be x square minus 3x minus 2x plus 6 equal to 0, right? And now can you see the factors? So if you factorize this, you're going to get x minus 3 multiplied by x minus 2 equals 0. So either x minus 3 is 0 or x minus 2 is 0, right? Which means the values of x are going to be 2 or 3, right? So these values of x are going to make the polynomial 0, right? And these values of x, we said, they are called the zeros. So these values of x are called the zeros, or they are also known as the roots of the polynomial. So you need to know these two terms. They are either called the zeros or the roots. So it's very simple. So to find the zeros, we need to make the polynomial equal to 0. So polynomial px is set equal to 0. That's our equation. And the solution of that gives us the zeros or the roots, which is those values of x that makes the polynomial 0. Now let's look at the next concept, the relation between zeros and coefficients of a quadratic polynomial. So let's say our quadratic polynomial px equals ax square plus bx plus c, where the coefficients are a, b and c, right? And the coefficient a is not equal to 0. Why? Because we want a quadratic polynomial, right? So we want that term x square in there. So a should not be 0. Okay? And let's say that alpha and beta are the zeros or the roots of the quadratic polynomial px. Then there's this important relation between the roots and the coefficients. So between the zeros and the coefficients. And what is it? That alpha plus beta is equal to minus b by a. So the sum of the roots is minus b by a, these coefficients. And the product of the zeros is alpha beta is equal to c by a. So these coefficients. Okay. So note these two important relations between the zeros and the coefficients of the quadratic polynomial. And if we know the zeros of the polynomial alpha beta, then we can write the quadratic polynomial as x square minus alpha plus beta into x plus alpha beta, right? So basically it's x square minus sum of the roots times x plus the product of the roots. So we can write the quadratic polynomial in terms of the zeros here. So note these important formulae. Now let's take a look at this question. Obtain the zeros of the polynomial root 3 x square minus 8x plus 4 root 3. and verify the relation between its zeros and coefficients. Okay, so remember, we are going to copy down that polynomial, and to find the zeros we need to set it to 0. So it's root 3x square, right, minus 8x plus 4 root 3, and we'll set it equal to 0. Okay, and now we can use middle term breaking to factorize this polynomial. So can you see that the sum is going to be minus 8 and the product is going to be 4 root 3 into root 3. So that's 12. So let's break the middle term like this. Root 3 x square minus 6x minus 2x plus 4 root 3 equals 0. So can you see that the sum is minus 8 and the product 6 into 2 is 12. Okay, so now let's factorize this. So it's going to be root 3x, and this is going to be x minus 2 root 3, and here we'll have a minus 2, so x minus 2 root 3 again, right, equal to 0. So if we group these, we are going to get the factors as root 3x minus 2 into x minus 2 root 3 equals 0. Okay, so what are the roots here, or what are the zeros? So x is going to be, so either this is 0 or this is 0, and so we have x equals 2 by root 3 from this one, right, and from this one also we'll get x equal to 2 root 3, right. So these are the zeros of the polynomial, of our quadratic polynomial, right. So we found the zeros here. This is our answer, and now we need to verify the relation between the zeros and the coefficients. So remember the formula that we learned, alpha plus beta equals minus b by a, and alpha beta equals c by a. So let's apply that. So what is our formula here? So let's write that down. Alpha plus beta equals minus b by a, right? The sum of the roots, or the sum of the zeros. And so that's going to be minus b by a. So what is the coefficient? So we are going to compare this with, remember what is the standard form of the polynomial, quadratic polynomial? Ax square plus bx plus c, right? And that we had set equal to 0. So here b is minus 8, and a is root 3, right? So this is going to be minus of, we have b as minus 8 here, and a is root 3. So what is the sum of the zeros going to be? It's going to be 8 by root 3. Okay, and now let's do the product of the roots. Alpha beta, the product of the zeros or the roots, is going to be c by a. That's our formula, right? So again we need to use our coefficient c and a. So what is the coefficient c? It's basically 4 root 3, right? And a is root 3. So root 3 cancels, and the product of the zeros is 4. Okay, and so to verify this relation, because we have used this relation, right, alpha plus beta and alpha beta, since we know the zeros, so we are going to use it and check if these values that we got using the relation, are they right or not. Okay, so that's pretty simple. So first thing you'll do is take alpha plus beta. Let's do that. So that's going to be 2 by root 3 plus 2 root 3, right? Okay, and there if we take the LCM as root 3, okay, so 2 plus 2 root 3 into root 3, that's going to be 6, and we are going to get 8 by root 3. Okay, so do we have the correct answer here? There you can see alpha plus beta is 8 by root 3. And that's what we had got from our relation minus b by a. So we verified that. And now let's quickly verify the product of the zeros, right? So we are going to solve for alpha beta. And that's pretty simple because it's going to be 2 root 3 into, 2 by root 3 into 2 root 3. Okay? And so the root 3 gets cancelled there and we get 4. So here if you take a look, we got alpha beta by using the zeros as 4, and that matches exactly what we got in our relation. So that's the main thing here in this question. First we used factorization and we solved for the zeros, and then we used our formula alpha plus beta minus b by a, alpha beta c by a, and got the values and verified that from the roots itself. And so you can see that it's matching. So the relation between the zeros and the coefficients is also verified here. So it's pretty simple, right? Are you ready for the next question? Here it is. If x equal to 2 by 3 and x equal to minus 3 are the roots of ax square plus 7x plus b equal to 0, we need to find a and b. So how do we solve this? Remember the concept? If these are the roots or the zeros, that means these values, if we substitute it in our polynomial ax square plus 7x plus b, it's going to be 0, which means it's going to satisfy this equation here. So let's write down our equation, which is ax square plus 7x, right, plus b equal to 0. And now let's simply substitute these values. So let's substitute. The first value is going to be a into 2 by 3 whole square, right, plus 7 into 2 by 3 plus b equals 0. So if we simplify that, we'll get 4 by 9a plus 14 by 3b plus 14 by 3, sorry, plus b equals 0. Okay, so this is our first equation. And now let's substitute the next value, x equal to minus 3, again in this equation, right? So what do we get? We are going to get a into minus 3 whole square plus 7 into minus 3 plus b equals 0, right? And so if we simplify this, we get 9a minus 21, right, plus b equal to 0. And that's our second equation here. Okay, and we can rearrange and write this equation as 4 by 9a plus b equals minus 14 by 3, right? So that was our first equation rearranged. And similarly here we have 9a plus b equals 21. Okay, so now it's pretty simple because we need to find a and b, and as you can see we have two equations. So right, so we have a pair of linear equations, two linear equations in two variables. So you can simply solve that, and if you go ahead and solve it, you're going to get the values. So try this out yourself. You're going to get a equal to 3 and b equal to minus 6. So that's going to be our answer if you solve these two equations. Note this important point, that if a is a 0 of a polynomial px, then x minus a divides px, or we can say x minus a is a factor of px. For example, let's say 2 is a 0 of a polynomial px, then we can say that x minus 2 divides px, or x minus 2 is a factor of px. Now let's solve this question. Find all the zeros of 2x cube plus x square minus 6x minus 3 if two of its zeros are root 3 and minus root 3. So how do we do this question? First let's write down our polynomial. So can you see it's a cubic polynomial here? So let's write that down. So let's say the polynomial fx is 2x cube plus x square minus 6x minus 3. Okay, and since we want to find the zeros of the polynomial, we are going to equate the polynomial as 0, right? Now we've been given that we have these two zeros, root 3 and minus root 3. Okay, so we can say that x minus the zeros of the roots, so it's going to be x minus root 3, and x minus of minus root 3 will be x plus root 3. So can we say that these are factors of fx, right? So these are factors of fx because they divide it, right? Because these are the zeros of this polynomial. So now if we multiply this, so it's going to be, you can use a plus b into a minus b, and it's going to be x square minus 3. Multiplying these two out, we get x square minus 3. So x square minus 3 is a factor of this polynomial fx. That means this is this polynomial can be divided by this, right? So if we divide these two, so if we divide the polynomial by x square minus 3, so let's write it like this. So x square minus 3, if we sit and do this division, so 2x cube plus x square minus 6x minus 3, right? So if you sit and divide this and you solve this, you're going to get the quotient as 2x plus 1. Okay, so now how can we find the other 0? So we've got the quotient as 2x plus 1. This means we can write this polynomial fx as fx equals x square minus 3 multiplied by our quotient here, which is 2x plus 1, right? So we're going to multiply this, right? And this is equal to 0. I'm just going to draw a line here, right, to separate these, and this is equal to 0, right? Which means that this factor 2x plus 1 is equal to 0. So we can say if we have 2x plus 1 equal to 0, we can write that down here. 2x plus 1 is 0. Therefore, x equal to minus half, right? So that's the other 0 of this polynomial, right? So using these two, we found the x square minus 3 and we divided it by that, and we easily got the other 0 of this polynomial. Ready for our next question? If the polynomial x to the power 4 plus 2x cube plus 8x square plus 12x plus 18 is divided by another polynomial x square plus 5, the remainder comes out to be of the form px plus q. Find the values of p and q. So how do you solve this question? It's pretty simple. You just need to divide this polynomial with this one. So let's write it down. So this is going to be our divisor, right? X squared plus 5, and we need to divide this long polynomial x to the power 4, so just write it down, plus 2x cube plus 8x squared plus 12x plus 18. And so let me extend this line right up to here, okay? And so you need to sit and do this division, right? It's simple algebra, so you need to divide it. So I'm not going to do it here. So I'll write down what's the quotient going to turn out to be. X squared plus 2x plus 3. So that comes out to be the quotient, and when you divide this, we'll get the remainder as 2x plus 3. Okay? And note that the question talks only about the remainder, not the quotient. So take care to compare just the remainder with the form px plus q. So this basically is going to be px plus q. Now it's pretty simple. You just need to compare the coefficients. So p is going to be 2, right? Just comparing the remainder with this form. So we have p as 2, and what will q be? Very simple. Q is going to be 3. Okay, so that's our answer here. Let's look at our next question. Find the zeros of x square plus x minus p into p plus 1. Okay, so let's write down our polynomial. So our polynomial fx is x square plus x minus p into p plus 1, right? Okay, and remember, to find the zeros of the polynomial, we need to equate this polynomial to 0. So that's our equation, and we need to solve for x here. Okay, so it's pretty simple, and first let's expand it out here. So x square plus x, and let's expand out these terms. So we are going to get minus p square minus p equal to 0, right? So now we need to factorize this to find the zeros of this polynomial. So let's take the square terms together. So it's x square minus p square plus x minus p. So we are doing this to factorize it. Okay, and can you see that form? A square minus b square, right? So let's write that as x plus p into x minus p, right? So that's that, and then we have plus x minus p equal to 0, right? So let's take x minus p common here. So what are we going to get? Into x plus p plus 1. Okay, right? So either this is 0 or this is 0, right? So those are our zeros of x. So we can have, so what do we have here? So x minus p is 0. So that's x equal to p, right? That's one of our zeros. And let's also equate this to 0. So x plus p plus 1 equals 0, which basically means x equal to minus of p plus 1, right? It goes to the other side. So here we found the two zeros of this polynomial. It's p and minus p plus 1. That's our answer of this question. And here's our final question. If the product of the zeros of the polynomial ax square minus 6x minus 6 is 4, find the value of a. Now, I'm not going to be solving this question because I want you to try it yourself.